Now, one thing that you have to know how to do before you can balance equations is if you have to know how to count atoms. And when you look at elements and their symbols and compounds and how they're written on paper, you're going to see some little numbers and you may see some bigger numbers. Okay? The little numbers are always attached to the element to the left. So if I'm looking at this right here and I see H2, that tells me that I have 2 atoms of hydrogen. If I see a little 2 with my oxygen, I have 2 atoms of oxygen. That number always goes with the one on the left. So when I look at water, I have 2 atoms of hydrogen and only 1 atom of oxygen, because oxygen doesn't have a little number. Sodium, there are no little numbers at all, so we assume that there's only 1, okay? Because it's kind of like with fractions, 3 over 1 is still 3. We can ignore the 1, okay? And besides, I can't make a compound if I don't have at least 1. And then if I look at this big one, this is the compound for glucose. That's the sugar that's in our fruits and vegetables. And it's C6H12O6. I have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Okay? Now, if I'm looking at a compound that has a big number in front of it, that big number goes with everything. The big number means that I have that many total molecules or compounds of that substance. So the big 2 in front of my water molecule means that I have 2 water molecules total. So instead of just having 2 hydrogen and 1 oxygen, I now have 4 hydrogen and 2 oxygen. Okay? We pretend that there's an imaginary synthesis right here in front. And like in algebra, here gets multiplied to everything that's on the inside. So 2 times 2 equals 4, and 2 times 1 equals 2. If we look at our big sugar molecule, if I have a 3 out in front of it, then that 3 is going to be multiplied by the whole compound. So 3 times 6 is 18 carbon, 3 times 12 is 36 hydrogen, and 3 times 6 is 18 oxygen. Okay? The little numbers can never, ever, ever change. The big numbers will change if a compound is separated or if it fuses with another compound to make a larger one. The big numbers can change, but the little numbers can never, ever change, which leads us into balancing equations. In order to balance an equation, you have to understand what's called the law of conservation of mass. Now, keep in mind, most of the stuff that chemists try and teach you and try to tell us and explain to us is based simply on faith. Okay? Science, like anything else, is basically what I consider a form of religion. You have to believe that your experiments that you're doing are correct. Okay? However, from a Christian standpoint, I do believe that the law of conservation of mass is true. I believe that God created everything with the snap of his finger, and everything that he created is all there is. I don't believe that he's going to create anything new. I think what he created is here, and I think that it's just being recycled with different things. Okay? It's not, you cannot destroy it. We are not strong enough to destroy something that God created. And so basically, the law of conservation of mass, I feel, is one of the few things that scientists have gotten right. And it states that matter cannot be created or destroyed. We cannot create matter. We can't destroy matter. Okay? So when we balance an equation, we have to remember that whatever goes into a reaction has to come out of a reaction. Now, let's go back to those little number 2s, the little bitty numbers that we saw just a second ago. There are some special atoms, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, that are always found in pairs. They're like Siamese twins. And you cannot separate them unless there is a reaction that occurs in which both of the atoms can be used. So when we see these, they're shown with a little number 2, H2, O2, N2, and F2. Okay? So when I was showing you the picture of creating water, And I showed you right here 1 hydrogen and 1 oxygen. That's not entirely correct. There is always going to be a second hydrogen over here with this one. Okay? These little guys with these special numbers right here, these special atoms right here, they are called diatomic. Okay? They are called diatomic elements. So they can never be separated. Okay? So when I do this and I try to create water, I'm always going to have a second one. Okay? They're Siamese twins. They're always connected. And so over here, I'm always going to have a second oxygen. Okay? They're always going to be together. They're never going to go anywhere without each other. So when I try to create water, I have to have a certain number of oxygen and a certain number of hydrogen, or I can never, ever, ever create create water. Okay? So I have 2 hydrogens floating along. Okay? They're trying to find someone who can help give them 2 electrons in their outer shell. Oxygen is floating around, and they're trying to find someone who can give them 2. They have 2 spaces that need to be filled. Well, this one little hydrogen can only fill this spot. This one little hydrogen can only fill that one. But this oxygen is not going to let go of its Siamese twin unless this oxygen has somebody that it can share electrons with. Okay? So you can never create water unless you have enough hydrogens to fill both of these spots. So when I made this one molecule of water, this oxygen right here is all left by itself because it's a Siamese twin. And this oxygen right here isn't going to let go unless he has enough hydrogen to make water out of as well. So I'm actually going to need another set of hydrogen over here, because we have to have enough hydrogen in order to fill all of the empty spaces on my oxygens. So when these 2 guys come down here, these 2 guys have to come over here. So in actuality, I'm going to create 2 water molecules every time I try to make water. Okay? And when we do this, this is where balancing equations comes into play. When you look, here is what I'm trying to do. We know that hydrogen plus oxygen equals water. And we know that water is made up of H2O. At least that's what the scientists tell us. So I have 2 hydrogen and I have 2 oxygen. Then when I create my water, I have 2 hydrogen. But I only have 1 oxygen. Can't happen, because the law of conservation of mass says that matter cannot be created or destroyed. So I have to come down here, and on paper, what I do is I tell my kids to make a chart. The atoms that are on the left side of the arrow and the atoms that are on the right side of the arrow. And I list my elements in the middle. To begin with, it's what's in green. I had 2 hydrogen. I had 2 oxygen. Then on my water side, I had 2 hydrogen, but only 1 oxygen. And that can't work. I've destroyed matter. So what I have to do is I have to have a multiple. We're multiplying, okay? So I have to find another oxygen atom. And so when I do that, which I do, I have one over here. He needs a friend, okay? So in order to do that, I have to have 2 water molecules in the end. And the only way to have 2 water molecules in the end is to start with 2 hydrogen molecules. Okay? So I'm going to multiply by 2, but that big 2 has to go in front because my water can't be separated. Okay? That's where these little imaginary parentheses come into play. I can't separate my water. So my 2 has to be put in front. So now I have 2 times 2, I have 4 hydrogen, and 2 times 1 is 2 oxygen. Well, now if I can't create elements, So that's where my little Siamese twin elements come into play, these special diatomic ones, okay? So I have to have two more sets of hydrogen in order to make water, okay?